Welcome to qnawire.
All right, guys, we're doing problem 38 of chapter 9 in Chemistry Central Science. So the pH 3 molecule is polar. Does this offer experimental proof that the molecule cannot be planar? So if the molecule was planar, there'd be three polar bonds pointing in three directions, each 120 degrees from each other. This would create symmetry, as pulling of the polar bonds would effectively be canceled out by pulling in the opposite directions. So let's say we have our pH pH 3 here. So when we would have, assuming it was planar, you would have the dipole moments going in each direction. In fact, I wrote them in the wrong direction. And then they would cancel out. That would create a non-polar molecule. But the fact that at pH 3 is polar, that shows those dipoles are not canceling out, so our molecule is not planar. So now, B, it turns out that ozone, which is OH3, has a small dipole moment. How is this possible given that all the atoms are the same? So let's draw sorry about that. Let's draw our ozone structure. It's O3. So there are two ozone structures. We have this one and we have this one. These are both resonant structures of ozone. My apologies. So your double bond can be either in this OO bond or this OO bond. So these are two resonant structures, so the overall structure is going to be this. There's a partial double bond character on both of these oxygens. So now, you can see there's a lone pair on the electrons in the middle of the oxygen. So these two bonds are equivalent. This OO bond is equivalent to this OO bond. But you'll notice because you have that lone pair, that actually negates the symmetry and will cause an unequal electron sharing distribution. Because you can think of this bond, this electron pair, you can think of a lone electron pair as kind of a pseudo bond. You're going to have electron character. You're like it's going to look more like this. It's going to effectively the lone pairs are going to have affect geometry in such a way that it is somewhat equivalent to a bond. So even though these two bonds over here are equivalent, this here is going to bend this lone pair up here is going to bend your structure and make it so that you don't have a net dipole. So you're going to have a small net dipole. And you can see from the molecular structure, the central oxygen is bonded to one oxygen with a double bond, the other with a single bond. Those are resonant structures. And although these are both equivalent resonant structures, that doesn't mean that they are technically equivalent, but it means that one is going to be favored slightly more than the other. So that's why it has a dipole. That's why it has a small dipole moment. Although it may look the same, and although these resonant structures may look the same, one is slightly favored more than the other.